Hi everyone, I am Ms. Maheswari, working as Assistant Professor in the Department of Computer Science and Engineering at PSR Engineering College, Sivagasi. Now I am going to lecture about Yarn, Apache Yarn. It's a resource management layer for the Hadoop ecosystem. Here, the overview is Big Data, Hadoop, MapReduce concept, and how to running a Yarn application, then types of scheduling, finally installation hints and programming models. Big data. Big data. The evolution of data generation is often described through the 5 V's of big data. It is a volume, velocity, variety, veracity, and value. These dimensions highlight the challenges and opportunities associated with managing and utilizing large-scale data in various forms. 5 is volume. Volume means the massive amounts of data. Then velocity deals with the high-speed generation and processing of data. Variety, the different types of data, different varieties of data. Veracity deals with the correctness of data. Finally, the value. Value insights from data. Hadoop. Hadoop is an open source framework that allows distributed processing of large data set across cluster of computers. There are two major components deals with Hadoop ecosystem, that is HDFS and MapReduce. HDFS is a Hadoop distributed file system that stores data across multiple machines. MapReduce plays a vital role in the Hadoop ecosystem for the programming model for processing large data sets. MapReduce. Obviously, it's a programming model for data processing. It breaks the processing into mapping and a reducing phase. Each phase has a key value pairs as input and output. Then Yarn. Yarn is a key component of Hadoop ecosystem introduced in Hadoop 2 version to address the limitations of the original Hadoop architecture. The diagram shows the difference between traditional resource management layer and the Yarn. In the traditional Hadoop, that is a version 1, a job tracker was responsible for both job scheduling and resource management, it leading to the scalability and fault tolerant issues. That's why we overcome the issues by using the Yarn concept. Fundamentals of Yarn. The Yarn is a resource scheduler. For the resource scheduling, it is split the data into MapReduce data flow, and then a separate scheduler allows for better utilization and scalability of the cluster. It is one of the non-MapReduce application. It is different from MapReduce applications. It is a non-MapReduce applications. It take advantages to the Hadoop distributed file system and a runtime environment. Finally, we move on to the anatomy of a Yarn application run. Steps. These are the steps to the Yarn application run. It provides a core services through two types of daemons. One is resource manager, another one is node manager. Resource manager deals with a one resource per cluster and it manages the uses of resources across the cluster. Then the second one is node manager. It running on all nodes in the cluster, launch and monitor the containers. Container means nothing but it executes an application specific process with a constrained set of resources. The diagram shows how Yarn runs an applications. These are the steps to run a Yarn applications in the pictorial form. Initially, the application client submit a Yarn application to the resource manager. Then the resource manager's node sends the heartbeat signals. Heartbeat signal is nothing but allocating resources to the node manager. It sends a heartbeat signal to the node manager and it launched to the container that has application processes. Then finally, the container runs a computation in the container and requests more containers from the resource manager. These are the steps involved in running an application by using the yarn concept. Benefits of yarn. More than hundreds of benefits. I represent the two important major benefits of yarn. Initially, it's a scalability issue. The yarn rectify the scalability issue by run on large clusters than MapReduce 1 version. MapReduce 1 version hits scalability resource manager. Scheduling and yarn. Scheduling and yarn is an important concept. Yarn scheduler allocates resources to the application according to some defined policies. There are three types of schedulers. They are FIFO scheduler, capacity scheduler, and fast scheduler. Both of these three allows long-running jobs to complete in a timely manner, and so concurrent smaller ad hoc queries are also processed in the reasonable time. Here, the figure shows the FIFO scheduler, that is first in, first out scheduler. The FIFO scheduler is the simplest scheduling algorithm in yarn. It allocates resources to applications in the order they are submitted, similarly to the queue system. How it works? FIFO scheduler works when the jobs are executed in the order they are submitted. The first job to arrive gets the resource first, followed by the next, and so on. If a job is running, new jobs have to wait until the currently running job is completed. The second one is capacity scheduler. The figure shows the function of capacity schedulers. Initially, the capacity scheduler provides more sophisticated resource allocation compared to FIFO. It allows user to define queues, each with a certain capacity of resources, which can be allocated to different jobs or applications. How it works? Resources are divided into a set of queues with fixed capacity. Each queue can hold different applications or jobs, and resources are allocated according to the capacity of the queue. Within each queue, jobs are scheduled based on priorities, and resources are shared according to the predefined strategy. Then finally, fast scheduler. Fast scheduler aims to allocate resources such that each job gets an equal share of the resources with the goal of achieving fairness. How it works? Resources are allocated dynamically to ensure that all the jobs get an equal share of resources over the time. If there are idle resources, the scheduler will allocate them to jobs that need them, allowing fair access across jobs and queues. It supports user and queue prioritization to ensure fairness, but the priority is based on equal resource distribution rather than FIFO order. Then, shuffle and sorting algorithm. By using the shuffle and sorting algorithm, the MapReduce makes a guarantee that the input to every reducer is sorted by a keypad values. The process by which the system performs the sort, that is, the transfer the map outputs to the reducers as input, is known as shuffle. Shuffle is the heart of MapReduce and is where the magic happens. Each map task has a circular memory buffer that it writes the output to. Here the diagram shows the shuffle and sort in MapReduce. We give the input set split as the data entering into the mapping phase, and then buffer in the memory, and partition sorting and splitting to the disk operation takes place, partitioning takes place, and merging on the task. It fetches these data fetched by the reduce phase. The map task is only mapping the input and partitioning, sorting the input, and then it brings to the reduce phase. Then the second part is reducing phase. Then we merge all the data from the mapping task and then sends to the reducing phase. And finally, we get the output as map reduced data as we want. Installation hints. We need three type of configuration for the installation. First one is configuring MapReduce site.xml by giving the value as yarn. Here the property name is mapreduce.framework.name and the value is yarn. Now the configuration of MapReduce site.xml is completed. Then the second task is configuring yarn site.xml. Now we configure the property name as yarn.nodemanager.auxiliary services. Then the value is given as MapReduce shuffle. And then the yarn.nodemanager.auxiliary services .mapreduce.shuffle.class. Then we give the value of MapReduce shuffle and short class name org.apache.hadoop.mapreduce.shuffle handler. Now the third one is yarn services. We stimulate the yarn services by giving those following commands and start the resource manager as well as the node manager and start the yarn services. Okay, finally, this is a web page for yarn resource manager. All the application run under the yarn. It's a purely a non-MapReduce applications. Thank you.